Hey guys, how was your weekend?
Good.
Good.
I didn't do that much.
Yeah, I just relaxed and did some homework.
How was yours? Did you do anything fun?
It was okay. I had a doctor's appointment though. It was supposed to be a regular checkup, but they told me I have high blood pressure.
What? How?
Wow.
But aren't you too young to have high blood pressure?
Does it run your family or something?
Yeah, the doctor told me that I have a family history of high blood pressure, and I thought the same thing too, that only older people have high blood pressure. But they said even though it might have been true in the past, these days high blood pressure affects people of all ages. I also apparently have too much sodium in my diet.
Too much sodium from what?
Basically, any food with a lot of salt. All that salt causes my blood to hold extra fluid, and that puts stress on my heart.
But as long as you keep to your diet and take medication, I'm guessing you'll be okay, right?
Yep, I should be fine. I wish I could see exactly what's going on in my body, though. Hey, look at Miss Frizzle's dress. That's a lot of red. Good morning, class. Today we're going to be taking a trip inside the kidney.
Hey, Steph, we could find out more about what's happening in your kidneys.
Let's go then, class. This will be interesting. Okay, I guess I'm ready.
Here we go!
So strap your bones right to the seat. Come on in and don't be shy. Just to make your day complete. You might get baked into a pie on the magic scuba. Step inside, it's a ride. Come on, ride on the magic scuba. Seatbelts everywhere.
Wow, this is so cool. But what is that bean-shaped structure over there? That is the kidney. It's a very important organ that filters fluid from our bloodstream, which allows toxins, wastes, and excess ions to leave the body in urine.
So it kind of works like a water purification system that keeps drinking water clean and gets rid of anything unsanitary, right?
Exactly. Whoa, awesome. Now we're going into the actual kidney.
Oh yeah, I remember learning about it on a TV show. There are 3 regions in the kidney: the cortex, medulla, and pelvis. The cortex is the lighter colored part that has a granular appearance, and the medulla is the darker reddish-brown section.
We should start seeing some nephrons soon. According to my book, nephrons are the structural and functional units of the kidneys. There's over 1 million of these blood processing units, and they carry out processes that form urine.
And each one contains a renal corpuscle and renal tubule. The corpuscle has a glomerulus and Bowman's capsule.
It looks like the capsule is that hollow structure that completely surrounds the glomerulus, and it's continuous with the renal tubule.
And the glomerulus is specialized for filtration. It's fed and drained by arterioles known as the afferent and efferent arteriole.
Since they're both arterioles, they would have a pretty high pressure, right?
Yeah, filtration produces a large amount of fluid, but almost all of it is reabsorbed by the renal tubule cells and returned to the blood.
Now we're passing the renal tubule, which is made up of the proximal convoluted tubule, nephron loop, and distal convoluted tubule. Then they empty into a collecting duct, which receives filtrate from the nephrons. They run through the pyramids and play a role in maintaining the acid-base balance of the blood. We've reached our destination, the Juxtaglomerular Apparatus. The cells surrounding the afferent arteriole are the granular cells. They are enlarged, smooth muscle cells with prominent secretory granules containing renin. Aren't they also mechanoreceptors that sense blood pressure in the afferent arteriole? Exactly. The other important type of cells are macula-densa cells. They're found in the distal collecting tubule. Does anyone know what they do?
Well, according to my book, they are chemoreceptors that respond to changes in the sodium chloride content of the filtrate. As you can see, they are tall, closely packed, and lie adjacent to the granular cells.
What are those third type of cells?
Those are the extraglomerular mesangial cells. They help form a communication between the macula-densa cells and the granular cells. So Steph has high blood pressure. But what would happen if you have low blood pressure? How does the body cope with that?
Well, it's all in the magic of the granular cells.
What happens there?
Well, when blood pressure is too low, the renin-angiotensin mechanism kicks in. Do you guys remember our friends, the granular cells? Yeah, they have renin inside of them. They get stimulated to release renin when they are less stretched or when the macula-densa cells sense low sodium chloride levels.
That sounds like a lot of work. How can one molecule change the blood pressure of the whole body?
Well, renin helps convert angiotensinogen into angiotensin 1. Angiotensin 1 can then be converted into angiotensin 2 by angiotensin converting enzyme.
Yeah, but what good is that?
Whoa, relax, Anthony. Angiotensin 2 is our friend. It constricts arterial walls, stimulates reabsorption of sodium, causes release of antidiuretic hormone, decreasing peritubular capillary hydrostatic pressure, and causes contraction of the glomerular mesangial cells, reducing GFR.
That sounds absolutely ridiculous.
It is, but it doesn't end there. Angiotensin II also stimulates aldosterone release from the adrenal cortex, which increases salt resorption. This increases blood volume and subsequently blood pressure.
Wow, you're right. Gotta love that kidney.
Well, I think that's all the time we have today, class. We've got to get going.
That was amazing!
Insanity!
Let's go again! Let's go again! Let's go again!
What happened? What did you guys see? Well, there was a lot going on, but it turns out that the Juxtaglomerular Apparatus plays a huge role in your blood pressure.
It's amazing the impact that just a few cells can have.
Let's go again!
No, that's all we have time for today, Christina. But it's just another day's work for the kidneys.